Okay, example 3 says to write sine of 5 theta plus cosine of 3 theta as a product of two trig functions. We don't have anything for sine plus cosine, do we? But remember, we know that sine and cosine are cofunctions, right? And so their angles have to add together to give us 90 degrees or pi over 2. So I'm going to come over here to the side first and do a little side note here. Alright, since they're cofunctions, remember we know that sine of theta is equal to cosine of pi over 2 minus theta. That's the cofunction formula for sine and cosine. So that means that sine of 5 theta will equal cosine of pi over 2 minus 5 theta. Does that make sense? And so since we know that, we can come over here now to our equation and we can change this. We know sine of 5 theta, we just said, is equal to cosine of pi over 2 minus 5 theta. Plus cosine of 3 theta. And now we're using cosine of x plus cosine of y. So let's see, I'm going to actually write the formula up at the top then. So we're doing cosine of x plus cosine of y, because I like to be able to look at it as I'm plugging it in. Just 2 cosine of x plus y divided by 2 cosine of x minus y divided by 2. So remember, this is our x and this is our y. So we go to do this, we have 2 cosine of x plus y over 2 times cosine, to move that a little bit, of x minus y divided by 2. Let's simplify what's in the parentheses. Remember, when it's divided by 2, that means each of these is going to get that divided by 2, okay? So we end up with pi over 2, which is pi over 4, minus 2 theta over 2, it's just theta. Same thing here. They both get the over 2. So pi over 2 is pi over 4. Minus, and then 8 theta over 2 is 4 theta. And it wanted us to get it as a product of two trig functions. We got a product of two trig functions because it's cosine times cosine. We've simplified it as far as we can, leaving it as a product of two trig functions. So this is our answer.